All right, so this is lesson 13.4. We're talking about compound interest today. And of all the things we do in Algebra 2, this one is actually pretty real world. You're going to come across interest rates like your whole life, anything that has to do with money, so it's important to kind of know how they work. So comparing compound versus simple interest, and I kind of wrote that backwards. Let me fix that. Okay, so simple interest says that if you start with $100, and you do 3% of that. Now remember 3%, we're going to multiply and we're going to change this over, right, to 0.03. And that's going to tell us that then we're going to earn $3 of interest that month, right? So what this simple interest, so just so you know, we're talking about simple right now, that's going to say like a month 2, you're still going to be doing 3% of what we call the principal amount. So each time you're going to earn $3. Okay. What compound interest says is that the interest will be counted not based on your principal, the starting amount, but on what is left, or what you have at the next marking point. So for instance, you're going to start with $100 and you're going to do 3%, which is going to give you it's going to give you $3, right? That's how much interest you'll earn. But then the next month, you don't have $100 invested anymore, or whatever you're, owe it, or however you're considering it. Now you have $103. So now you're going to do 3% of $103, which is going to give you 3.09% interest earned that month, or charged. And then we'll do that again. So now we're at like 106.09. times 3%. So you can see, and we've done this, this should remind you of like a geometric sequence, because this is growing, exponentially every time, that this is very different. So I want to remind you of some formulas. All right, so remember, these are all kind of related formulas. So geometric sequence, remember we start with the first term, so we make the exponent n minus 1, and then r, there is your ratio, right? So today we're going to be doing a lot with percents. So R in our exponential growth, this is our percent as a decimal. And remember, we count up from 1. So if we did 3%, this is really 1.03 that we would be using. And remember N in this case is the number of terms. And A, so notice because this is N this time, let me see if I get my pointer, because this is N, A is like the original amount. So it's not after like the first day or the first time it's compounded, it's the original amount that you invest, which makes more sense with money. You usually start with the 0 term instead of the first term anyway. So today we're going to be talking about more specifically this compound interest formula that you see at the bottom here. This P, I've been saying this word already, it's principal. It's like the money word for what you call the original investment that you make. It's the same as A. And this time you'll see a T up here, because when we talk about investing and compounding interest, we're talking specifically about time, and not just about like a number of terms. All right, so let's look at one quick example here. A person invests $200 in an account that earns 6.25 annual interest. Find when the value of the investment reaches $5,000. Okay, so this one says they invest 200, so that's your P. So if I write this, this is Y equals P1 plus R to the T. Okay, so I know P. I know this interest rate, and I remember I need to turn it into a decimal, so 0.0625. That's my R value. And then reaches 5,000. So this is different. It's asking when. That's what I don't know. So I don't know T. And reaches 5,000, that's going to be the value that it reaches. So when I set this up, it's going to say 5,000 equals 200 times 1 plus 0.0625 to the T, because I don't know T. Now this should look familiar to you in terms of the exponential and logarithmic equations we've been solving, because now our goal is just to get T by itself here. So the first thing, just like we've done before, the first thing I need to do here is divide by 200. It's going to give me 25. Oh, fix my decimals there. 25. Got carried away. is going to equal, now I am going to add what's inside there just to make it easier. So this is 1.0625, that's not hard to add, to the t. And so now I'm just trying to solve for this exponent. So I'm going to do my log equation. So I'm going to say log 1.0625. I know my exponent needs to be on the other side. And so 25 goes right here. So now I'm ready to just type that in my calculator to figure out the time. And when I did that, I got that t was 53.09. So if we're talking about, when, this is saying annually, so that's going to be 53 years. So it's going to take 53 years to get all the way up to 5,000 at that, when you're investing that amount at that rate. Now here's the thing. Of course, you're like, it can't be that simple. It's algebra 2. It's possible for things to be compounded more than once a year. And in all reality, most of the things that you are going to invest in, bank accounts, loans, student loans that you take out, or any personal loans, most of those things are not compounded annually. They don't wait an entire year to compound on that interest. They compound it more regularly than that. So there's another formula which is called the compound interest formula, and it is y equals p 1 plus r over n to the t n. So notice there's an extra variable in here. You know what p is. P is the principal amount. You know what r is and what t is. So the new term here is this n. And what n tells us is basically how regularly or how many times per year is it compounded. And so just to help you make sense of this formula, the reason you're dividing right here is because you're dividing the percentage, like if it's 10% or whatever, by the number of times it happens. So that percentage is being divvied up each time it's compounding over the year. The same kind of thing is happening here. If it happens, if you invest for 10 years, but it compounds monthly, then that's 10 years times 12 times each year, right? That's why we're doing that. So let me give you some common n values. So semi-annual would be 2 times per year. So the n value would be 2. Quarterly is going to happen 4 times per year. Monthly will happen 12 times per year. Weekly, it's 52 times per year. There's 52 weeks in a year. And daily is going to be 365. Okay, and we're going to see a trend here in a minute. There is also something called compounded continuously. So notice I'm increasing every time. Compounded continuously means it's happening infinitely. But the problem is I can't put an infinity symbol in my equation. My calculator's, 1, I can't even type that, and 2, my calculator's not going to understand what that means. So instead, we come up with this whole new formula for compounded continuously. This is also on your formula sheet. And it's called, you're going to hear this one a lot because it's one that is used most regularly in the real world. It's called PERT. And so PERT uses E, the value E. So P is still your principal, R is still your percent, T is still your time, but now you have this E value down here at the bottom. And what I want to remind you is that E is just a number. So there's actually an E button on your calculator. It's underneath where the pi button is. So remember how pi is 3.14, It's a constant, right? E is also a constant. So E is approximately 2.718, blah, blah, blah. And we don't see it as much in other things, which is why you've learned pi and you haven't learned E yet, but that's what E is. All right, so this time we're talking about investing $200, 6.25%, but now we're talking about compounded weekly, and we're asking the same question, when will it reach $5,000? So when you compound weekly, remember now your answer is, your n value is 52. So I've got 5,000, that's what I'm looking for, is $200 invested at 1 plus. Now look back at your formula that you just wrote down. It's R, so 0.0625 divided by n, so divided by 52. Let's get that out of the way. To the nt, so to the 52 times t. So now I need to work this out. So the first thing I would actually probably do in my calculator is simplify this part on the inside. That looks messy and like something I don't want to deal with. I guess I'm also going to divide by 200, so I'm going to do those two things at the same time. So I'm going to divide by 200. Okay, and that's going to give me 25 equals. Now, when I typed this in my calculator, I turned it back into a fraction because I don't know, I don't want any like rounding error to happen. It's easy to come up with. So I ended up getting 833 over 832. You can ask me about that if you're not sure tomorrow. 52 to the t. And now we're going to do the same thing that we did just a minute ago. We're going to go to our log equation. So this is log of this fraction, 833 over 832 of 25 equals 52t. And when I find that value, so I'm going to use a calculator again. I got this 2,679 number equals 52. And then I'm going to divide 52t, and then I'm going to divide by 52. And so I got, this time I got t equals 51.5. So notice now I'm at 51.5 years. And if you remember from that first example, I think I was at, I can't even remember now, it was either 52 or 53 years. It was 53 years. So notice that when I compounded more regularly, the timing becomes less. So let's talk about how we set up daily and continuously and see if that trend perpetuates. So for daily, my formula is going to look the same. It's going to be 5,000 equals 2,000. Now the difference, 200. The difference is this time, instead of dividing by 52, it's going to be daily. So I need to divide by 365 because there's 365 days in a year. Then I'm going to do 365 times my value t that I don't know. If I did continuously, remember this one's the whole different formula. So I'm going to do 5,000 equals 200, and then it's e to the r 0.0625 t. Now I'm going to solve both of these equations out. Okay, so I went ahead and solved these because I don't know that you need me to go over those steps, but I want to give you the answers so we can talk about the last piece of this, last connection to make. So this first, when you compound daily, I got 51.50, and so I'm going to go back and show you this first one. Weekly was 51.53. Here I get 51.50 in terms of time. The last one I get 51.50. I'll even carry it out another decimal place. This is 6 and this is 2. So the last thing that I want you to see is just how these compare. So these are our 4 examples that we kind of did today. All were invested the same amount. We were looking for $5,000 at the same percentage rate. And notice that the more frequently it compounds, the quicker it gets there. So, right, this is 51.5 years versus 53.5 years. And it's very minute difference, kind of in between there, but that's going to cut off a good amount of time and will also mean that if you're investing, just know that continuously grows quicker than annually does, which would be good if you were investing money, and that's going to hurt you, obviously, if we're talking about interest on like a loan or something, because that means you're going to owe more in the end than if it were compounded less regularly.